On April 24, 1990, the Space Shuttle Discovery launched the Hubble Space Telescope into low Earth orbit. After some initial technical problems, it began providing images of our universe, the likes of which we have never seen before. Even though larger, better telescopes have since been sent to space, for over 30 years, Hubble has remained one of the most important instruments available to astronomers. Learn more about the Hubble Space Telescope, why it was created, and what it's accomplished on this episode of Everything Everywhere Daily.
Hey, do you have trouble sleeping? Then maybe you should check out the Sleepy Podcast. It's a show where I read old books in the public domain to help you get to sleep. It was the best of times. It was the worst of times. It was the age of classic stories like A Tale of Two Cities, Pride and Prejudice, Winnie the Pooh. Stories that are great for adults and kids alike. For years now, Sleepy has helped millions of people catch some much-needed Z's, start their next day off fresh, and discover old books that they didn't know they loved. So, whether you have a tough time snoozing or you just like a good bedtime story, fluff up the cool side of your pillow and tune into Sleepy. Unless you're driving, then please don't listen to Sleepy. Find Sleepy on Spotify or wherever you get your podcasts. New episodes each week. Sweet dreams.
This is Chris Christensen from the Amateur Traveler Podcast. The Amateur Traveler Podcast is about the love of travel. It's about where to go and why you should go there. We're going to open up to you different destinations you haven't heard of, or places you have heard of, but things you didn't know to do while you were there. Each episode is about 45 minutes long, and it's typically an interview with someone who wrote the guidebook on that destination, or who has been there, or who's a local tour guide, or someone who is an expert on that destination and knows how to tell you what to do to get the most out of your precious vacation time. So if you value your vacation time and you want to use it wisely, listen to Amateur Traveler and learn about destinations both domestic and international, places you've heard of and places you haven't. Amateur Traveler has almost 900 episodes talking about different destinations. So if there's a place you want to go, odds are we've already covered it and can help you plan a trip there. Amateur Traveler, subscribe today.
The Hubble Space Telescope is one of the most important single scientific instruments that has ever been produced. It has advanced the science of astronomy in ways that weren't possible before. It has produced images that have astonished and amazed everyone who's seen them, and it began the era of large-scale space-based astronomy. Before I get into the specifics of the actual construction and deployment of the Hubble, I should first explain why the idea of a space-based telescope was proposed in the first place. The idea of a telescope in space, beyond the atmosphere of the Earth, actually dates back to before the space age in 1946. The Princeton theoretical physicist and astronomer Lyman Spitzer published a paper titled Astronomical Advantages of an Extraterrestrial Observatory. In the paper, he gave several reasons why a telescope in space would be superior to a telescope on Earth. There were actually a host of reasons why a telescope in space would be better than one on Earth. Most people think that the main reason why a space telescope is better is due to light pollution. That is a reason, but it's actually down the list of the major reasons as to why you'd want a space telescope. So, why put a telescope in space? The biggest reason is atmospheric turbulence. The Earth's atmosphere is turbulent, which causes starlights to twinkle and blur. This phenomenon limits the resolution of any Earth-based telescope. There are some techniques that have been used to minimize this, but it can never be eliminated so long as you view something through the atmosphere. The next reason is atmospheric absorption. The Earth's atmosphere absorbs and scatters certain wavelengths of light, including most ultraviolet, X-rays, and some infrared radiation. This limits the range of wavelengths that ground-based telescopes can observe. The third reason is the day-night cycle. Earth-based telescopes can only observe the sky at night, limiting observation time and making continuous monitoring of celestial objects difficult. In space, you aren't limited to a few hours. Depending on where the object you're observing is located, you can point the telescope at it for days or weeks to get very long exposures. Fourth is that you don't have to worry about clouds or weather. The reason why most major Earth-based telescopes are located on mountaintops or in deserts is because it allows astronomers to maximize the number of days that they can observe. And finally, you do have the issue of light pollution, which is an issue, but not the biggest issue. Spitzer's paper was an incredible insight considering how little we knew about conditions in space in 1946. At the time, nothing had ever been put in orbit, and while scientists had a pretty good idea of what conditions would be like in space, they had absolutely no data on anything. Spitzer devoted much of his career to the advocacy of a space telescope. In 1962, the National Academy of Sciences came out in support of a space-based telescope. And in 1965, Spitzer was named the head of a commission that outlined the objectives and goals of such a telescope. While Spitzer was a big advocate of a space telescope, the person that really drove the project internally at NASA was Nancy Grace Roman. Roman was the first female executive at NASA, and in the 1960s and 70s, she served as the chief of astronomy in NASA's Office of Space Science. As NASA's internal advocate, Roman became the driving force in the 1970s for what was then known as the Large Space Telescope, or LST program. She was an astronomer who independently proposed a space-based telescope back in 1959 before she began to work at NASA. Throughout the 1970s, Roman lobbied not just NASA administrators, but also members of Congress to get approval for the project. After decades of trying, Spitzer and Roman's work finally bore fruit when Congress approved the budget for the Large Space Telescope in 1977. When the new program was launched, its director was Nancy Grace Roman. Just as an aside, the way NASA got approval for the program was rather sneaky. Originally, they were going to get a token $5 million for the project, but the NASA Associate Administrator for Space Science, Noel Hinners, decided to eliminate the budget entirely. He wasn't against the program, but he realized that $5 million couldn't get the project off the ground. So instead, he proposed $0 for the program to galvanize the scientific community. And the ruse worked. Here I should note that there were small-scale telescopes launched in the 1960s that were more of a proof of concept. NASA launched the Orbiting Solar Observatory, or OSO, in 1962, and the Orbiting Astronomical Observatory, or OAO, in 1966, and OAO-2 in 1968. All of these missions were limited, and OAO-1 actually failed after 3 days, but they did show that space-based astronomy was possible. Moreover, all of these missions made their observations in the ultraviolet or higher frequencies. The Large Space Telescope was going to be totally different. For starters, it was going to be, large. It was going to have a primary mirror of 3 meters or 9.8 feet in diameter. And second, it was going to conduct observations in the visible part of the spectrum. Finally, the plan was that the telescope would require periodic maintenance by astronauts throughout its life. The planned 3-meter mirror was eventually reduced to 2.4 meters as a cost savings measure. The LST was going to be one of the key projects behind the entire Space Shuttle program. As with any government program, various components were distributed to different companies. The European Space Agency also contributed solar panels and other components in exchange for European astronomers to get 15% of telescope time. The initial plan was to launch the telescope in 1983. And that did not happen. The project was plagued by cost overruns and delays. The 1986 Space Shuttle Challenger disaster delayed things even further. In no small part, one of the reasons for the delays was because nothing like this had ever been done before, and there was nothing to base projections on. In 1983, the name of the telescope was changed from the Large Space Telescope to the Hubble Space Telescope, named after the astronomer Edwin Hubble, who discovered that there were galaxies outside of the Milky Way. It wasn't until 1991 that the telescope was ready to be launched, and the Space Shuttle program was back on track after the Challenger disaster. Finally, it was launched into space on the Space Shuttle Discovery on April 24, 1990. With the cost overruns and delays, the mission ended up costing over $6.7 billion in inflation-adjusted 2024 dollars, the most expensive mission ever at that time. The mission went off without a hitch, and the next day the Hubble was taken out of the space shuttle and put into orbit. As the mission team back on Earth began running tests and getting the telescope up and running, they found a problem. A really big problem. The telescope was out of focus. The mirror was one of the most finely polished telescope mirrors ever made, yet the grinding process was done incorrectly. The outer edge of the mirror was too flat by 2200 nanometers, and that was enough to cause spherical aberration and reduce the image's sharpness. An investigation into the problem found that one of the testing devices for the mirror was off by 1.3 millimeters. The telescope wasn't totally useless, as they were able to make some simple observations, but it was far from what was intended. After decades of planning and billions of dollars spent on the Hubble, there was now talk of abandoning it. The mirror simply couldn't be replaced. It was too big and too integral to the telescope, and to replace the mirror, you'd probably have to replace everything. Eventually, a solution was discovered. While the mirror was incorrectly ground, it was precisely ground. The solution was to add a layer of adaptive optics that would correct the problem. In effect, they put a pair of glasses on the telescope to fix the issue. The fix was known as the Corrective Optics Space Telescope Axial Replacement, or COSTAR. The telescope was scheduled to have service missions even before the problem with the mirror was discovered, so this was addressed in its first service mission in December of 1993. Servicing the Hubble was one of the most difficult space missions ever up until that point. It required 5 separate spacewalks. However, in the end, the COSTAR fix was deployed, and it worked. Hubble was now working as intended. The images started coming in, and they were like anything that had ever been seen before. Of particular interest was an image taken between December 18th and December 28th, 1995. It became known as the Hubble Deep Field image. Time in the telescope was given to astronomers who applied for telescope time. However, 10% of the time was allocated to director's discretionary time. Robert Williams, the director of the Space Telescope Science Institute, came up with a radical idea. He was going to devote most of his discretionary time for 1995 by pointing the telescope to a section of the constellation Ursa Major that seemingly had nothing there. And it wasn't selected at random. That part of the sky was out of the galactic ecliptic and was mostly free of stars located in the Milky Way. The part of the sky that was observed was very small. It was 2.6 arc minutes, which is roughly 1/24 millionth of the entire sky. And to put it in more relatable terms, the area that it took an image of was about the size of a tennis ball when seen across a football field. Preparation for the exposure actually took almost a year. And over a 10-day period, the Hubble took 342 separate images of that small portion of the sky. The results astounded both astronomers and the general public. The image showed that the tiny patch of sky with nothing in it actually had over 3,000 distinct galaxies that could be seen. Not stars, but full galaxies. The astronomers were astounded because many thought that Hubble was incapable of seeing galaxies that couldn't be seen from the ground. And the public was amazed because it was just an incredible image. This was just one of several discoveries made by Hubble. Others include detecting and analyzing the atmospheres of exoplanets, capturing detailed images of star-forming regions, enhancing our understanding of stellar birth and evolution, providing strong evidence for the existence of supermassive black holes in the centers of galaxies, improved measurements of the Hubble constant, refining the scale and age of the universe. It observed gravitational lensing effects, proving a theory by Albert Einstein, and in 1994, it captured images of the impact of comet Shoemaker-Levy 9 on Jupiter. After the 1993 mission to fix the Hubble, 4 more service missions took place in 1997, 1999, 2002, and 2009. New equipment was added, and some components were replaced. There hasn't been a service mission of the Hubble in 15 years now. A proposal for a private firm like SpaceX to conduct a service mission has been suggested, but as of this recording, nothing's been decided. Having been in orbit for over 34 years, the Hubble is showing signs of its age. Several gyroscopes that stabilize and orient the telescope have failed, and power issues have started cropping up. The original plan for decommissioning the Hubble was to bring it back to Earth on the Space Shuttle and put it in the Smithsonian Air and Space Museum in Washington, D.C. As the Space Shuttle program is now over, that option is gone, so the current plan is to simply deorbit it. If nothing is done, it will eventually drop out of orbit on its own sometime between 2028 and 2040. During the last service mission in 2009, an adapter was put on the Hubble that would allow a remote spacecraft to latch onto it to provide a more controlled deorbit. As of the time of this recording, no firm plans have been made regarding the end of its life or even possibly extending it. If a service mission were sent to the Hubble and new gyroscopes and components were installed, then there's no reason why it couldn't continue to operate for several more decades. Until a decision is made, Hubble will keep limping along, still able to provide astronomical observations from space. If and when it goes offline for good, there will be other space telescopes to take its place. The James Webb Telescope was launched in 2021, has a much larger mirror than Hubble, and has made several discoveries since its deployment. In 2027, NASA will be launching the Nancy Grace Roman Space Telescope, a tribute to the woman who's considered to be the mother of Hubble. The Roman telescope will have a mirror the same size as Hubble, but will be located outside the orbit of the Earth and will have a 300 megapixel camera. The Hubble Space Telescope stands as one of the most successful and influential scientific instruments ever built. Its journey from conception and launch through all the delays and mirror problems ultimately has paved the way for future space telescopes and has expanded our knowledge of the universe. The executive producer of Everything Everywhere Daily is Charles Daniel. The associate producers are Benji Long and Cameron Kiefer. I want to give a big shout out to everyone who supports the show over on Patreon, including the show's producers. Your support helps me put out a show every single day. And also, Patreon is currently the only place where Everything Everywhere Daily merchandise is available to the top tier of supporters. If you'd like to talk to other listeners of the show and members of the Completionist Club, you can join the Everything Everywhere Daily Facebook group or Discord server. Links to everything are in the show notes.